MCQs from organic chemistry, that is previous year NEET questions. Which of the following reactions is appropriate for converting acetamide to methenamine? Now, acetamide is a primary amide. Say CH3, C double bond O, NH2. Now, this is to be converted to methenamine. That is CH3, NH2. Again, so this is a primary amide and this is a primary amine. Now, you can see that this has one carbon less than this compound. So let us look at the options. The first one is carbylamine reaction. So carbylamine reaction we know is used to detect primary amines. So that won't be using chloroform and ethanolic potash. When you heat the compound, you get foul smelling carbylamine or isocyanide. So that is not the option. Then next is Hofmann-bromamide reaction. So for Hofmann-bromamide or in Hofmann-bromamide reaction, you convert a primary amide to a primary amine. Now what do? You heat it with or treat it with bromine and a strong base like sodium hydroxide or potassium hydroxide. So you convert the C double bond O or it gets removed as a carbonate and you end up with a primary amine which will be having one carbon less than the amide which you started with. So Hofmann-bromamide reaction will be option B will be the correct choice. What about the other two? Stefan's reaction, that is for nitriles, partial reduction of nitriles. RCN will become RCHO aldehyde using tin chloride SnCl2 and HCl. That is Stefan's reaction. Then Gabriel thalamide reaction, that is for preparing pure primary amines from alkyl halides, where you are using potassium thalamide. So option B is the correct choice in the first question. So that is a NEET 2017 question. Next, second question is identify product A in the following reaction. So here you can see two keto groups, two carbonyl groups are there, a diketone, treatment with zinc amalgam and concentrated HCl. So that is that reaction. It's a named reaction, you call it Clemmensen reduction. So in that, aldehydic or keto groups are reduced to, aldehydes or ketones are reduced to alkanes. That is, the C double bond O becomes CH2. So let us see which of these options, in which of these options C double bond O is changed to CH2. So this one, option D will be the correct choice. That is also a NEET question 2023. Third question. Paper chromatography is an example of partition chromatography, thin layer chromatography, adsorption, column chromatography, adsorption chromatography. So paper chromatography is an example of, say, partition chromatography. In this, you have a stationary phase, and that stationary phase is also a liquid phase, which is water molecules trapped in chromatography paper, which is cellulose paper. And the mobile phase, that is also liquid. It will be a solvent, That's a suitable solvent carrying the sample components. So more soluble component or more soluble components in the mobile phase. Mobile phase is the solvent that will move faster, whereas components which are more soluble in the stationary water phase will move slower, and thus they get separated. That is why they get that partitioning or separation happens. That is why we call it partition chromatography. So it depends on the relative affinity of components to the two phases. To the mobile phase, if it is more soluble in the solvent, it will move up fast. Or if it is more soluble in water which is trapped in the cellulose paper, it will be slow, or it will move slower, and thus the two components can be separated. So paper chromatography is an example of partition chromatography. That's a NEET 2020 question.